These are the solutions to the review sheet for Unit 7. I know it says, sorry, not Unit 7, Unit 8. So first problem, you're given a data table. We're looking for m of -10. So an input of -10 has a value of 0 for m. For g, a value of 6. Subtract them, -6. Here, we're doing m of g of 10, not multiplying, but first we want to find g of 10. G of 10 is -6. So we're looking for m of -6, which is 2. G of -6 is -3. We're going to take that output and plug it as an input to z. Z of -3 is 2. M of 0 is -1. Z of 0 is -7. We're multiplying these, we get +7. G of -3 is 4. 4 is going to get plugged into m. M of 4 is -10, and -10 gets plugged into z. Z of -10 is -4. Here we're going to take 10, plug it into g, we get -6. Take -6 and plug it into g again, we get -3. Take -3 and plug it into g again, you get 4. One more time, g of 4, -8. Here we're given functions with equations rather than a table. H of 1 and f of 1. So we plug in 1 to f, and we subtract what happens when we plug in 1 to h. 4 minus 2 is 2. Minus 2 plus 3 is 5. You get -3. G of 4, and here's g, is 4 squared. H of 4, 2 times 4 plus 3. You get 16 over 11. Here, r of 13 is inside. R of 13 is natural log of 13. P of that of 13 is e to the natural log of 13. E to the power and natural log are inverses, so they cancel, and you get 13. J of g of x. J, our outside function, is square root of g of x, which is x squared, minus 4 from what j of x was. It had a -4. We can reduce that to be absolute value of x minus 4. F of x is 4x minus 2. Careful with your parentheses. G of x is x squared. We want to multiply, and we get 4x cubed minus 2x squared. And then f of h of x. F is 4 times h of x, which is 2x plus 3 minus 2. We get 8x plus 12 minus 2, 8x plus 10. On the back, we're looking to graph this function. There are 3 pieces. The first piece is a line with a y-intercept of 2 and a slope of 3. Well, this one goes a little bit off the graph, it appears. So we want to start at -1 with an open circle and go back until we get to -5. It has a closed circle on the other end. Our second graph is a parabola. It's shifting left 1 and down 1, and that ends up starting at the exact same place the last one finished. And it has a change of over 1 up 1, over 1 up 3, over 1 up 5, and over 1 up 7. That is going just off the graph as well. It should have an open circle at the end, and we connect our dots. And then the last graph is a square root graph, which is shifted right 3 and up 7. We go up 1 over 1, up 1 over 3, and this one will continue on forever, so we put an arrow. And the second to last question, we've got a function. We're going to write the equations and the domain in which each occurs. The first one is a line with a slope of 3, and the y-intercept we can see by continuing the line over 1 up 3, over 1 up 3. It would intersect at 8, and it goes from an x value of -6 until -2, an open circle on either end, so we do not put equal to on those. The second piece is a parabola that's shifted right 1 and down 3, and it goes from -2 until 3, and it has closed circles on the ends. It reaches those. We put an equal to on the inequalities. And the last graph is a horizontal line at -8, and it extends from -3 open until 9 closed. And our last question, we're looking to use the functions f, g, and h. And there's one more here, k, to write a composition. And I'm seeing 2 to the power, and I'm seeing a square root, and 4x plus 5. So I'm thinking f, g, and h. H is on the outside, and into that we plug in the square root, but inside of the square root we plug in f, and that is our composition.